sequence, which is in this blue box here. So this is a thing that you're going to see in your formula sheet. So a sequence is the sum of a list of ordered numbers. What that basically means is just a sequence is the sum of a lot of numbers, kind of added up together, obviously, because there are some. I'll get into some examples later if that explanation doesn't make sense. This is the recursive definition of an arithmetic sequence. As I said, this is a thing you're going to see in your formula sheet. What it essentially means is that the next term in the sequence, the tn plus 1, is going to be equal to the term before, tn plus the difference. So what this kind of looks like graphically is if you have tn and then tn plus 1, to get from tn to tn plus 1, you need to add the difference. And then, of course, over here, we're going to have tn plus 2. To get from this one to this one, you're going to add the difference. And then over here, we might have tn take 1. And to get from tn take 1 to tn, we're going to add the difference. So all this basically means is that to get from one term to the next, you just need to add the difference, which is going to be a constant number. So some examples of arithmetic sequences include 1 plus 2 plus 3 plus 4 plus 5. So as you can see, we have a sum of a list of ordered numbers. So we have a sum, it's 1 plus 2 plus 3 plus 4 plus 5. It's not like 1, 2, 3, which you might have understood sequences to be before. Our sequence is in order. And as you can see, the difference between each of these numbers is 1. So to get from each number to the next, we're adding 1. This example here, our difference is of course -2, because to get from each number to the next, we are going to be taking away 2. This one here, our difference is going to be 50, because from each one we are adding 50. So, before we move on, one other thing that I should mention, and I'd recommend just like taking a quick little note of this to come back to later in the year. When you're learning geometric sequences in class, you're going to need to be able to distinguish between arithmetic sequences and geometric sequences. So as I said, we're not going over geometric sequences today, but when you do them in class, you're going to need to be able to distinguish between the two and kind of look at a question where you might need to use a sequence formula and determine whether you need to use an arithmetic sequence or a geometric sequence. So, we won't go into the arithmetic sequence one today, but the important thing to know about we won't go into the geometric sequence one today, but the important thing to know about the arithmetic sequence is that it has a constant difference. So that means that to get to the next term, you're always adding the same constant number. So you're always going to be increasing by 2 or something like that. So when you read a question, you need to be able to determine whether the difference between each new term is a constant number. And if it is, then you need to apply the arithmetic sequence. So yeah, take a note of that for when you get into geometric sequences and you need to distinguish between the two. Okay, this is the more common equation that we use for the arithmetic sequences. The last one is just kind of more so of a definition, This one is the one we're mostly going to be using because this formula down here, it tells us what any term will be given only the first term and the difference. But our last equation only allows us to find the next term from the previous term. This equation allows us to find any term within the sequence at all. We'll get into a few examples of this again in a second. But the reason that this formula works is actually quite simple if you just kind of think about it intuitively. So, if you want to find the second term using the recursive definition that we went over before, we're going to get the first term plus the difference, right? So the next term in a sequence is going to be the previous term plus the difference. The third term is going to be the previous term, term 2, plus the difference again. And so on for term 4. So as you can see, the pattern here is that to find a particular term, we need to add one less amount of the difference. So to find term 4, we need to add 3 lots of D. To find term 3, we need to add 2 lots of D, and so on. Another way to represent this visually would be if you have term 2, term 3, term 4, and term 1. To get from term 1 to term 2, we need to add one lot of the difference. To get from term 1 to term 3, we need to add 2 lots of the difference. To get from term 1 to term 4, we need to add 3 lots of the difference. So, this is why our general term works. So as you can see, when we need to find term 4, we need 3 lots of the difference, term 3, 2 lots of the difference, term 2, 1 lot of the difference. So it's always one less than this number down here. So as you can see, to find term n, we need to get term 1, and we need to add n take 1 lots of the difference. So to find term 4, we need to get term 1, and we need to add 3 lots of the difference, which is exactly what we have shown in this diagram up here and in this written out version down here. So that's why our formula for the general term of the arithmetic sequence works. I find that it's usually really helpful to understand like where the formulas in your formula sheet come from, just so that you like actually have a better conceptual understanding of the ideas, and it generally helps too with the complex unfamiliar questions. If you understand the actual concept, because that means that you can extend the concept to kind of new contexts. If you would like any more tips on the complex unfamiliar questions, just because I know they tend to be the questions that really separate people from like more of a average level to like a really high level, just because they are so hard. Please ask me in the chat as well if you have any specific questions. I'll chuck in some tips throughout the lecture, but yeah, if you have any specific questions, please ask. Okay, getting onto an example. So